Hi, today I will guide you through an introduction to time-resolved photoluminescence. I will teach you how to properly configure the instrument to suit your needs, as well as fix the desired parameters and settings to allow experiments to run smoothly. Okay, let's get started. This is the fluorimeter. Light enters this device from the source lamp and travels to the sample container, where it is then diverted to one of two receivers. For steady-state experiments, light will be diverted to the receiver on the right. For time-resolved experiments, light will be diverted in the opposite direction, to a receiver capable of capturing and processing the desired time-resolved data. The fluorimeter's default source of light in this lab is the lamp power supply box, powering the xenon bulb used for steady-state experiments. To get ready for time-resolved experiments, we first want to switch from the xenon lamp source to the LED laser. If you have just finished running steady-state experiments and the lamp supply box is on, be sure to turn it down to 10 amps and wait 5 minutes before turning it off. You want to carefully unscrew the fitted ring that attaches the xenon lamp to the fluorimeter, and then move the xenon lamp box to the side so that it is out of the way. Now, remove the LED laser from the bag and attach it to the fluorimeter at the same site where the xenon lamp was just attached. Additionally, plug the cable attached to the LED laser into the slot labeled V2 on the fluorimeter. This next section will cover how to switch the sample container from a liquid sample holder to a solid sample holder. If this does not apply to you, please disregard this next section. Okay, you want to remove the screws keeping the container in place. Make sure to remove any cuvettes that are in the container beforehand. After, you need to disconnect the two cables attached to the bottom of the sample holder before you are able to completely disconnect it from the fluorimeter. Now you can replace your liquid sample holder with your solid sample holder. It is recommended that you place your sample in the holder before you screw the solid sample holder into place. Otherwise, it is difficult to carefully place the glass slides into the holder. Also, make sure you screw the holder back in to prevent outside light from reaching the sample. Once your sample holder and light source is in place, you want to ensure the instrument is set up for a time-resolved experiment. First, angle the sample so that light hitting it is then diverted towards the time-resolved receiver. Check to ensure that polarizers are in the beam path. If they are not, slide them both into the beam's path. Also, check the filter holders to ensure that the correct number of filters desired for your tests are present. Turn on the PX01 box located under the monitor. Also, flip the switch to turn on the fluorimeter. Now you need to go to the lab computer and adjust the settings for the time-resolved experiments. Open the experiment application located on the desktop. Once open, you will be prompted to pick between two options. Choose Chronos BH. Now go to the Acquisitions tab. Check that the sync bar on the left is at 1.54 MHz, signifying that the LED laser is detected. Once you see the laser is detected, press the Outputs Enabled button on the top right of the screen and drag Gain A to 88%. Click and drag your mouse from right to left until you see the signal peak. This will ensure that you get the max signal on your plot when running your experiments. Check to ensure that the instrument is in time-resolved mode. Look at the top left of the window where it says Format and check that the leftmost box is picked so that time-resolved receiver is ready to run. Make sure the range is 650 nanoseconds. If the signal disappears from viewable screen, click and drag your mouse until it is in view again. It is important not to drag the signal once you start the experiments, or else the IRF and sample peaks will not line up along the x-axis, preventing you from being able to fit your data properly. Now, click on Experiment tab, choose Time Domain, and then pick Lifetime. If you're using the liquid sample holder, which contains two holders, one for the sample and one for the reference, then for Collect IRF, choose Always. If you are running experiments using the solid state holder, choose Never. You will test your IRF separately and will run it under the same conditions you test your samples. Next, you want to set your upper limits. If you would like all of your samples and references to contain the same peak, which is helpful for fitting the IRF with the samples, choose your upper limits so that the peak is the limiting factor. The experiment will be stopped once one of the upper limits is reached. In fixed parameters, check that the left emission polarization is at 54.7 degrees, the magic angle, and that the excitation polarization is at 0 degrees. You can also do this on the Acquisition tab. Great! Now you are ready to run an experiment. I will walk you through the testing of a sample to help you get started. First, press the play button to begin your experiment. If the intensity box representing the amount of signal hitting your receiver is red, that means too much intensity is coming through. Immediately stop the experiment. You can solve this problem by adding filters, or by manipulating the amount of light allowed to pass through the iris. It is not necessary for each sample to have the same number of filters, or the same exact level of iris opening. Rather, it is more important that the receiver is receiving data at similar intensities from your samples and IRF. This can be done by manipulating the iris to line up the CFD bar at around the same levels for each test run. Awesome! Now we will let the experiment run. The experiment is done. It has now reached the upper limit, set at a peak of 100,000 for this particular experiment. Vinci, the program used to analyze our data, should now open. To fit your data, choose the Fitting tab and click Lifetimes. If you need to overlap your IRF onto the graph, choose Fitting Model, Show More Parameters, select IRF, and then double-click on your IRF Data tab. The pink decay will be the IRF, and the blue decay will be your sample. To choose the range of the data the program will try to fit, you can move around the bars as shown on the screen. Once you are ready to fit, go back to Fitting Model, guess a reasonable lifetime, and click Fit. If your residual looks like there is a pattern, this could mean there's a second lifetime. Click the plus button in the Fitting Model tab and guess a reasonable second lifetime. Sometimes, even though you have inputted a correct number of lifetimes, the program will still give you a messy residual. This is due to imperfections of the fitting software. To solve this, move around the range the program is set to fit until you achieve a good residual. Great! Now you can fit your data. Now you just need to make sure to leave the equipment as you found it. This involves replacing the solid-state sample holder with the liquid sample holder and switching the LED laser out with the xenon lamp. Make sure to screw back in all the screws and to screw the fitting ring snugly around the xenon lamp fluorimeter connecting site. Congratulations! Now you know how to perform time-resolved experiments and the fitting that follows.